In this example, we are going to compare two different methods to finding the volume. And so let's kind of walk through this here. It says, let R be the region bounded by the graph of y equals the square root of x in the y-axis and the horizontal line of y equals 2. Find the volume of the solid generated when R is revolved around the y-axis using disks and shells. So if you're going to rotate around the y-axis, you have to shift everything into terms of y. Not everybody loves that. And so we have another option, which is leaving it in terms of x's and using a method called shells. So we're going to compare the two on this problem and just kind of see what you think. So I'm going to start with some sort of a visual. So I'm going to graph this. So we're basically talking about the first quadrant. And I am bounded by y equals 2. We're focusing on the y-axis, and we're kind of rotating around that axis. So of y equals 2, I have to square root 4 in order to get to a height of 2. So just to kind of get some information and plot the points nicely, square root of 1 is 1, 0 is 0. And so here's my visual. And I am rotating around the y-axis. Here's my upper bound, and this is the shape that we're focusing on. All right, and so we're going to revolve this around. We do disk method. We're going to rotate around the y-axis, so we need terms of y. All right, so if we're going to be doing disks, we're going to be focusing on an equation that has this kind of a look to it, where this is the area of the base times the height. And so we're going to be subbing in some values for this. So our volume is, we need to turn everything into terms of y. So our first thing is our equation is not in terms of y. So we need to take this y equals the square root of x and square both sides. So putting things into terms of y is us solving for x. So our equation is, remember that we're taking these distances and we're rotating it around, and it's creating these cylinders. And so those distances out are based on the y value that we're plugging in and squaring it to get that x value. Right. So we're going to go from, in terms of y, we're going to go from 0 to 2 pi. This radius is going to be our x value, which is y squared. And then our height is our thickness on these cylinders, which is going to be not dx, but dy. Okay, so that's the math that I got going on. Let me clean it up a little bit here. We're going to pull the y out always. Sorry, the pi out always. We're going to go 0 to 2 of y to the 4th dy. We'll do our antiderivative and get y to the 5th over 5. We'll add a power, divide by that power. We're going to go from 0 to 2. So then we'll plug in 2. We'll plug in 0. Let's see what we get. So we have a 2 to the 5th over 5 minus 0 to the 5th over 5. And so that's going to leave us with 2 to the 5th is 32 over 5, and then that's just going to go away. So that pi times this, which is going to equal 32 pi over 5. All right, so that is our volume of that shape rotated around. So we're going to do the other method. Not everybody loves to shift everything in terms of y. And so you could use the shell method. So the shell method allows us to leave it into terms of x. It's already in terms of x, so then we just leave it in terms of x. Right? So with that idea, our equation that we're looking to set up is going to be 2 pi x f of x dx kind of a thing. So what you have here is you're talking about cylinders. You're talking about a circumference measurement. So it basically turns into these prisms, these rectangular prisms that are length times width times height kind of a thing. And so this ends up being the width because this is the circumference. This is the height of that rectangular prism, and this is the thickness associated to it. So for our volume, let's go ahead and go back and draw a picture because we have to think of it different. So we can't think of it like this. So I'm going to need to start my picture over. So I'm still going to go 1, 2, 3, 4, and then 1, 2. So I'll plot my points. And this is what we're rotating around. But if we're doing things in terms of x, we are looking at this length right there that is creating these shells, rotating it around and around and around. And so we got to figure out what those are, and there's going to be a bunch of them, and they're all changing in length. So how do we do that? So this distance right here is our radius, which is our height, basically. So our height is this piece. So this is our height. We don't know what it is, but we're going to have these little heights that are going to rotate around, and depending upon where we're at on the square root, these heights are going to be different. So how do we figure out these lengths right here? Well, that length is initially 2, because it goes all the way down, but we need to subtract out this piece. And what we would have left would be this piece, which is what we're looking for. So we're going to be subtracting out the square root piece. So that's how our heights are all going to be dictated. So that's our height. So let's go over to our equation. We're going to leave everything in terms of x. So we're going to go from 0 to 4. We have 2 pi x. That x is always just an x. It's this that is potentially a little complicated of us trying to figure out what that equation is. So it's going to be 2 minus the square root of x dx. So that's the math that we got to do. So let's rewrite this so we can do our antiderivative. We'll take the 2 pi out. We're going to go from 0 to 4. If I distribute this in, that's going to be a 2x. And this is an x to the 1/2 power times another x. It's going to be x to the 3/2 power dx. And then let's do the calc here. So 2 pi is still 2 pi. I'm going to add a power and divide by that power. So if I add a power and divide by that power, I'm going to have x squared divided by 2, which is going to cancel that away. So that's just going to be x squared minus, I'm going to get add a power here, which is going to make it a 5/2. And I'm going to divide by that power, which is going to be divided by 5/2 or multiplying by its reciprocal. And then we're going to go from 0 to 4. Okay, so let's plug in our stuff here. So 2 pi, we'll plug in 4, so that's going to be 4 squared minus 2/5 times 4 to the 5/2. So that's the first piece. And then minus, if we plug a 0 in, we just get a 0. Right, and so let's continue going through the math here. So we have, that's just going to be a 0, so we have 16 minus, the square root of 4 is 2, 2 to the 5th is 32, times the 2 that's already there is 64 fifths. So if I make that into fifths, we're going to have a 2 pi times, if I multiply that by 5, that's going to give us an 80 fifths minus 64 fifths. So 2 pi times, that's 16 fifths. And if I multiply 2 pi times 16 fifths, I get 32 fifths. 32 pi over 5. So 2 different approaches, depends on what you're comfortable with. If you're okay shifting everything into terms of y, go for it. If you really kind of don't like that, then you can leave it. You just have to use a different method with a different formula. But then just kind of realize what's going on with your heights. You may have to find the difference between some values to figure out those heights.